We already revised the concept of work and potential energy. Now let's look at an electrical example of these basic concepts. So let me draw two metal plates which have opposite charges. And sets up a uniform electric field in the downward direction. Now, let's suppose a charged particle enters in the field. This is my charged particle. Let's draw, make it different. Okay. The field exerts a downward force with magnitude F is equal to Q naught E on this. A to B. As the charge moves downward from A to B, the force on the charge is constant and independent of its location. The work done by the electric force would be same for any path from A to B. Either it comes like this or it comes like this, because electrostatic force is conservative. So the work done by the electric field distance between the two plates Q naught E into D. So the work done by the field is the product of the force magnitude and the component of displacement in the downward direction. Here the work is positive because your displacement and the direction of force is same. Also, the y component of the force is constant and there is no x or z components. It is in analogy to gravitational force on a mass m near the Earth's surface. The x and z components are also zero in that case. Because of this analogy, we can say that the electric force by the uniform electric field is conservative just as gravitational force. It shows that work done by the field is independent of the path of the particle takes from A to B. So this work can be represented by a potential energy function U, just like in the case of gravitational potential energy. The potential energy of the gravitational force is equal to mgy. Hence, the potential energy of the electrostatic force is equal to Q naught E y or Q naught E into D. When the test charge moves from height YA to YB, the work done on the charge by the field is given by So in this case here, if I assume YA and YB, the two distances, then it would be equal to D. Okay, now let's draw one more figure. Now the charge is moving downward. Positive charge at some point B, and this is point A. The distance from here to here is YA, and this one is YB. If YA greater than YB, it means that positive test charge moves downward in the direction of field. The displacement is in the direction of force. So the field does positive work and potential energy decreases. Now let's make another figure. Now, when YA is less than YB, the positive test charge moves upward in the opposite direction to electric field. Here the displacement is opposite to the applied force. So the field does negative work and potential energy increases. Now, let's see what will happen when the test charge is negative. Okay, let me draw again the same figure with a negative charge in it. So here this is my negative charge, and naturally it will move upward, and it is at it is point A and the distance is YA. Now let's suppose the charge is coming down at some point B and the distance is YB. Now, if the charge is moving in the direction of electric field, the force is in the opposite direction to the displacement. It means that field is doing negative work and potential energy in this case increases. Now, let's draw one more figure. Now, if the negative charge is moving, this is the direction of your electric field. Negative charge is moving upward. These are some 2 points, say A and B and YB and YA. Put the distance of this one and this. So now, if charge is moving towards the positive plate, because it's a negative charge, it means it is moving in the direction opposite to the direction of the field. In this case, field does positive work on charge and potential energy decreases because your displacement and force is in the same direction. Remember few points. Whether the test charge is positive or negative, potential energy increases if the test charge Q naught moves in the direction opposite to electric force. Now, or second is potential energy decreases if the test charge moves in the same direction as your force. So this is the same behavior which was observed for gravitational potential energy, which increases if a mass m moves upward opposite to gravitational force and decreases if mass m moves downward in the same direction as the gravitational force. So this concept of electrical potential energy is not only confined to uniform electric field, it is applicable to point charges as well. In our next video, we will see how electric potential energy of 2 point charges behave. Thank you.